So welcome back to CS 199 EMP sessions. Thanks for coming. So let's get into it. So today's topics are upcasting and downcasting, which we talked about briefly in our last session on Friday. But we're going to go over it one more time, and then we'll do some more advanced examples. And then we also have references and shallow and deep copy. So references, I think you guys covered yesterday, and then shallow and deep copy you briefly discussed last week, and then also it's relevant to your lesson tomorrow, or not tomorrow, today. Yeah. So upcasting and downcasting. So you can think of the two terms as kind of climbing up a ladder, where like the top of the ladder is the object class, and every rung on the ladder is like essentially a layer of classes. And so upcasting is going up the ladder or going to a higher class in the hierarchy, or going up to a parent class if you're the child class. And remember that this is like very easy to do in Java. It's just a matter of equality statement from a child class to a parent class. And it doesn't really have any issues, but the only thing is you lose some methods and variables that you normally would have in the original class. So if your child class is dog and dog has the method woof, if you are upcasting it to pet, then you're losing the property to call the woof function. And just remember that this is what upcasting looks like. So if you have pet one equals dog equals new dog. This is what upcasting looks like, right? So if your dog has a wolf property, one cannot call it unless you downcast it back into a dog. Which brings us to downcasting. Downcasting is going back down the ladder. So it's like going from dog back to, going from pet one, which is a pet, back to a dog, and then calling that woof method that dog has. So yeah, so that's downcasting, and downcasting is just a little bit more complicated because you have to check if this instance is in fact an instance of a dog, and then based off of the result of that, then you can downcast it into a dog, because pet, remember, can be a dog or a cat or a fish or whatever. And so you have to check if it is a valid instance using instance of. So here's an example that we have just for the movie class. So the parent class is movie, child class is romance, which is, I guess, a genre of movie. And we have some upcasting going on right here. So we're creating a movie class that is an instance of the romance class. So it's a movie, but it's underneath, it's kind of a romance movie class. And then when we try to run dot get cheesy rating, which is a method inside of romance on this movie object, what happens? Do you guys know what happens in that case? I'm gonna put it in the chat what will happen if we run this first line of code here. So I guess the question is not really what happens, but like, will this code run? Will line 17 run? Yes or no? Right. Do you know why? It's okay if you don't know why, but it's related to upcasting, right? Yeah, movie can't cheat. Movie can't cheesy. That's right. So movie doesn't have access to these methods that are exclusively in romance, even though on the like hidden under the layer, this movie is a romance movie. It can't access it. And so it'll say variable, I mean, it says method, get cheesy rating. What is that? It doesn't know what that is because movie doesn't have that. So it's going to throw an error. And that's just because movie could be a romance movie, it could be a horror movie. If there's a different kind of movie class, it could be any one of those, right? So there's no guarantee that get cheesy rating will be available. So Java's like, I don't know what that is. And then there's a second line of code which will run because it's part of this original movie class. Get rating. So when you're upcasting, just remember that the only things available to you are the things that are available in both the child class and the parent class, or just in the parent class. Yeah. So first practice problem on upcasting and downcasting. So we have the movie class from this section. Try to come up with another class that should descend from movie. So we talked about romance. So what would be another genre maybe that would be relevant, and try to come up with like a unique method that that genre could have. So like in romance, we had get cheesy rating, but maybe there's another thing that you can think of that would be unique to your example class. And then the second part of it is to create a movie object, just like we see here in line 15, that is an instance of the child class that you came up with in part 1. And once you've done that, you need to downcast the movie object from from the second part into your child class, and then have it call the unique function that you came up with in 1. So yeah, we'll do that. It's a downcasting example, and all you have to do is create your second, I mean your own class. Create your own class. I'll give you guys 5 minutes to work on that. So let's regroup at like 6:16, maybe 6:15, seeing depending on how difficult of a problem this is. Remember that if you're downcasting, that you should be using instance of to make sure that you're it's a valid instance and things like that. So let's see what you come up with. And feel free to let me know in the chat when you finish. Okay, so it's 6:16, so I'm gonna go ahead and start reviewing. It's okay if you weren't able to finish. I get that it takes some time. Okay, looks like everybody's done. Right, so first problem was creating your own child class. I'm gonna name my class international for international movies. And we use the extend keyword, create, make an account class, and it's gonna have an integer variable. Oh, I guess that doesn't make sense to have an integer. I'm gonna create a string variable called language. Okay, and it's going to return, oops, public. It's gonna have a method called get language. It's gonna return the value of language. Okay. Then the next question was to create an instance of movie. Sorry, create a movie object that is an instance of the class that I just created. So here's some upcasting. Okay, so that should work. And movie. Okay, great. And now I'm gonna call. So I can't call get language as it is like on Parasite. Parasite doesn't have access to get language. So I need to be able to call get language, and in order to do that, I'm going to downcast it. Parasite. So first I'm going to check if Parasite is actually an instance of international. And if it is, then I'm going to deviate. I'm going to downcast it. Downcasting equals international parasite. and then parasite that get language. And now since it's an international, it's of type international language, footage, I can easily call get language, or should be able to call get language. Yeah, so that works. So that's a good example of upcasting and downcasting. Okay. I hope that gives you a better visual of what all of that means, because we have another upcasting and downcasting problem. And this one's a little bit different. It's not related to the movie class. So you're going to create a method called vet visit, and vet visit is going to, let's kind of say that it's basically going to take in a pet parameter and return a string that is the type of the visit that the pet came to have at the vet that day. Wow, this is going to be a challenge to say. So depending on what kind of pet is passed in, the vet visit will return different things. So you can assume that all pets have a Boolean method, or a method that returns a Boolean value called isRegular. And isRegular basically indicates whether the pet is a regular at the vet. And you're going to have to use that. But these are the three conditions. So if the pet is a dog, you're going to, and if the pet is a dog and he or she is a regular, then the visit will be a regular grooming. If the pet is a dog but not a regular, the visit will be a parasite prevention session. So you're just going to return these strings inside of that visit. So make sure that you are downcasting it correctly, or I guess you don't need to downcast anything here. Make sure that you're using instance of correctly to check if you have the right instance of pet, and then return based off of the instance. Yeah, so pretty similar to your homework problem actually. But I don't think you guys will have any trouble with it. Let's do 10 minutes on this one. It's just a little bit more coding. But if you guys finish earlier, just let me know in the chat. I'll give it 1 more minute. Looks like most people are done or close to finishing. Okay. Looks like everyone is done. So I created a class, a pet class, and some dog, cat, and hamster classes, just so you know what it looks like. So let's get into the logic. So the first one is for dog, right? So you gotta check if pet P is an instance of the dog class. Um, then you want to check if P is regular, is a regular visitor at the vet. In which case you want to return regular grooming, right? And else return parasite prevention program, parasite prevention session. Okay, and in this example of the pet class, I just hard coded and drew for simplicity's sake, but don't assume that about is regular, so make sure you call is regular rather than hard coding them, or rather than ignoring that fact. That's true. Okay, so the next one is cat. So if it's a cat, we don't need to check anything. We just need to return cat wellness session or wellness exam. And then finally, if P is an instance of hamster, and we want to return dental care visit. Great. And then finally, if it's not a pet and if it's not one of the pets described above, you just return null. So none of these cases work. Okay, so I think that is it for this problem. Any questions on this downcasting stuff, upcasting stuff before we move on to the next topic, references? Okay, I'm gonna keep moving. All right, so references. I think this was yesterday's lesson. Just remember that reference is basically a kind of a label on an object or like a way to point to the object. So some of the good examples that we saw in the lesson were if the house is the object, then the reference, this should be address. I don't know why. Okay, typo here. This should say address, not reference. So if the house is the object, the address is the reference. If the phone is the object, then the phone number is the reference. The student is the object, then the UID is the, I guess it's UIN, isn't it? Not UID. Yeah. Then UIN is the reference. Okay. So another typo there. So remember that you can only create a new object with the new keyword. So if you see two examples of the new keyword being used, then you can assume that two objects are being created. Whereas references don't work like that. References you can pass along to another variable using this equal sign. And then remember that variables just store references to the object, and the references can point to objects or nothing at all, like null. So in this example, we've got a jet class or a jet string, which is my private jet, and then a plane, and another plane. Okay, so how many objects do we have here, and how many references do we have here is the question. So how many objects do we have here? Any ideas? Yeah, one, right. There's only one example with the new keyword, so you can pretty much assume that there's only one object, which is jet. But how many references do we have? Yeah, so it's technically it's 3, I guess. Because this is one reference and this is 2 references. And this is technically the original object, but it's also a reference because variables hold or they store the references to this object. So I would say it's probably 3. 3 would be the acceptable answer. Okay, cool. So some more stuff about references. Right, so if you change the underlying object of the reference, then all of the other references or all the other variables that point to that object will also see that same change, right? If you have a student and you change the value of that student's name and you have another reference to that first student, then that will change the value that the second reference points to. So in this example, you have a new student, Akhila, and here at this point in line 5, Akhila or Aki.name, which is a reference to this original Akhila object, its value is just Akhila, right? It was created with Akhila. So if you reassign Aki.name to be Aki, so I guess, using my name like this really wasn't a great idea because it's super confusing, but let me read this. Okay, so I have student 1, student 2. Okay, so if you student 1 and student 1 dot, and then I create another student 2, which points to this original student 1. At this point, Aki dot or 2 dot name is a keyword, right? But then I changed 2 dot name to be Aki, which changes the original reference also. So now this is also Aki. I hope that made sense. I didn't think that one out when I wrote Aki and Akila, confusing. Okay. So question for you guys. Does copying a reference copy the original object? And an example of copying the reference would be maybe like this line, this assignment line. Would it copy the original object? Thoughts, yes or no? So remember that an example of copying the reference would be line 5, right? You're copying this reference over to this reference. Copying a reference does not copy the original object. It's the same object, you're just pointing to it with a different thing. So like an example would be if you have a house and the house has an address that you write down on one sheet of paper, and then you copy that one sheet of paper to a second sheet of paper, and then that's creating a copy of that original reference, but that doesn't create a copy of that first house. So you're just creating two different sheets of paper that have the address on it, but it doesn't create two different houses, basically. Yeah. Okay. Some more about references in Java. So here's another example with the student class. And right, so this example is really all about equality and what is reference equality versus instance equality, right? So we have these two things. We have the double equal sign and we have the dot equals, which I think everyone is pretty much familiar with both. And you normally use the double equal sign for everything, but you usually use dot equals with strings, and whenever you're working with strings, we're always telling you, hey, use dot equals instead of the double equal sign. And that's because the dot equals is testing instance equality, whereas the double equals tests reference equality. And so what I mean by that is, for example, you have two students, A and B, right? And you're checking to see if A and B are two, so A and B are two different objects, right? We have two uses of the new keyword, so they're two different objects, but they both have the name or the value jockey, right? But if you wanted to check if student A and student B have the same value jockey, then you would use line 19, right? Line 19 is using the dot equals method to check to see if Jackie in student A and Jackie in student B are the same. Whereas if you were checking if the original object is the same, you would want to use the double equal sign because the original object is different, right? There are two instances, there are two objects being created here, and so they're not the same. And so whenever you're checking to see if the underlying object is the same or not, you're going to check if you're going to use the double equals. When you're checking to see if there's an instance equality, like checking to see if, like in the case of strings, if you're checking to see if string Jackie is equal to string Jackie, then that's checking for instance equality. So then in that case, you would use dot equals. I hope that made sense. I know it takes some time for it to sink in, but that's the gist of it. Double equal sign tests for reference equality. Dot equals tests for instance equality. So here's the first problem on this. You're going to create a method called compare movie that takes two movies. If the references for the two movie objects are the same, then just return a string called past test1. If the instances for the two objects match, then return a string called past test2. Otherwise, just return failed. So here's some starter code to help you guys with that. And okay. So here is your compare movie method. And you're just taking in two movie objects. You're going to check to see if they have the same references, if they have the same instance equality. And we've overridden the dot equals method for instance equality. So you can use that as a guide. Yeah, and let me know when you guys finish. We'll do 5 minutes for that one. So we'll regroup around 6:49 maybe. Yeah, you would create the method inside the class, like just like we have right here. You would just write your code in here. Okay. So looks like we're all at a good point. All right, so we were asked to compare for what was it for first? We were asked to compare for reference equality and instance equality. So if we've got two movies first and second, you always want to check for reference equality first because of course you can have instance equality. If two references are the same, then the instance is also going to be the same. So if you want to check for reference equality, then you want to check for that before you check for instance equality. So if first equals second, so that's just reference equality. And Does it say past test 1? Yes. And all right, so that's good. And then maybe then after that, you would want to check it. First spot equals second return past test 2. Okay, so now we're checking for instance equality, like with a string. You're checking to see if the string objects have the same value rather than checking to see if they have the same underlying object. Okay, and then finally, you're gonna return failed, right? All right, looks good. So I've got some test cases here that I've written out to see if this works. Okay. Oh, no. All right, so the first two test cases return past test 2 and past test 1. So that looks okay, but then I got a null pointer exception here. Basically, it's saying that I tried to call dot equals on a null. So what I need to do is I need to check for dot equals. I can check for null before I check for dot equals. So I'm just going to do another if statement in here. So first equal null, or second equal null. Sure, this problem looks familiar to you guys. If that's the case, then return fail. Okay. You can always also move this null check at the top if you want to. It's another way to do it. Okay. Great. All right, so now it says pass test 2, pass test 1, failed and failed, which is what we expect because in this case, B is null, and in this case, it's a different reference and a different instance. Okay, so that one was fun. Can you write if null equals null? Well, what would that do? So you're going to be checking for reference equality. Well, let's see. We'll see what happens, I guess. We'll just make E be null. And then we'll run the E. Okay. Yeah, so I guess you can write that. And basically, I guess what happens if you try to check if null is equal to null, it passes the reference equality test, meaning the underlying structure is nothing, which makes sense, right? Like null is the same regardless of like whether it's this null or this null. That's all the same. Yeah, good question. All right, next topic. We got about 7 minutes left. Right. So copying objects in Java, that's the next kind of, next problem. So you're working with all these objects, but is there a good way to copy it? No. At least not with like a built-in function. There is the clone function that Java provides, but it's not recommended for various reasons that I won't really get into. But there is something called copy constructor, which is basically a pattern or convention that was adopted by Java programmers to copy objects. So you've got a class called movie, basically, in this example. And movie will, this is a example of a copy constructor, because this is a constructor, obviously, because it's just a movie. And well, let's double check this. Which class movie? And movie takes in another movie object, and it's called rating, and string director, and right. And normally you would have a regular constructor for movie, and it might have two strings. Well, actually, I'm going to simplify this a little bit for the sake of writing. And it's just going to take an integer called separated. Okay, and then it's going to set rating to equal set rating. That's a regular old-fashioned constructor for you. And then what a copy constructor would look like is it would do the same setup for movie, or like a regular constructor, except instead of taking in a rating, it's going to take in another movie object, and basically it's going to set rating to be equal to the object's rating. And so how you would call this copy constructor is you would just do constructor, you would do movie one. It would just be like movie. You already have a movie called one, then you would just set maybe two new movie, and in the constructor you would pass in one, right? Right. And this would just print out. Okay, so here you were creating a movie object one and a movie object two, which is a copy of this original movie object. And now you're calling the original movie object and you're seeing what the rating is, and it matches with one's rating. The point being that this is what a copy constructor is. It's just another kind of constructor that copies the original object that's passed in. Now, two things to know here. There are two kinds of copies that you can create. One is a shallow copy, which is just this is a good example of a shallow copy, really. It's just it's referencing, it's not copying over it's not creating a completely new object, but rather it's kind of copying a reference to the original object. And so shallow copies are different from deep copies because deep copies create a whole new object that is a replica of the original object. And one way to think about this is if you've got like this array here, values, and then you call the copy constructor on values, and then you create a new array called scores. Scores is going to really just point to values. Like you call the copy constructor and you copied it over, but really the underlying array is the same. It's just a pointer to the same object. So that's what's special about shallow copies. In the case of a deep copy, you've got a class like bird, and then you call the copy constructor on it. You create a completely new bird. See, basically, a new bird. That's keyword, right? New bird. So you know that a new bird has been created because the word new has been used. So keep that in mind. Shallow copies are kind of just pointers to the original. Deep copies are completely new object. Great. So there's only 1 minute left and there's 2 problems left. I won't make you guys stay for another 15 minutes to finish the 2 problems, but do check them out. Pretty easy to do, I think. First one is just creating a shallow copy, just like we did here. It's actually the exact same thing that we did here, so I guess you don't need to do that one. And then the second one is a deep copy example where you've got an array and you can actually create a deep copy. To do this problem, just remember that you need to use the new keyword. So think about how you would use the new keyword with arrays, and think about how you would create this with a shallow copy also. So that's it for today. Thanks for coming by. If you have questions on the last 2 problems or any of the other stuff, let me know. We learned a lot of stuff. Upcasting, downcasting. We did some references. We did some shallow copies and deep copies. But yeah, you should be pretty prepared for your quiz today. If you have other questions, let me know. If not, that's it for me, guys.